Hello everyone, so in this video let's talk about the photocyclization reactions. Now if you remember, we have talked about the photocycloaddition reactions in our previous video. So in this case we are going to little bit different about the reactions because we are more talk about the aromatic structures. Now as for examples, I will take these particular reactions, right? I have drawn the structures here. Let's go with the mechanism. Now before we go into the real reaction mechanism, I want you to introduce few facts about these photocyclization reactions. First step is that these are considered reactions, which means that when the reaction when the reaction happens, the bond breaking and bond forming, okay, bond breaking and bond forming happens simultaneously. So these are concerted reactions, okay, or otherwise we can say concerted mechanisms, okay. So through these concerted reactions, otherwise a concerted mechanism, a non-aromatic compounds, a non-aromatic product will be obtained, right? So through this we can obtain a non-aromatic product, or we can say non-aromatic polycyclic compound. As you can see here, this is our initial compound. So when the first reaction, like when first step happens, this first step is the concerted step. This happens through a concerted mechanism, and this obtained product, right, the result of the first step is a polycyclic compound which is non-aromatic. As you can see, there are two hydrogens which are coming out of the plane, which means these are not aromatic compounds. Through these non-aromatic compounds, okay, through this non-aromatic compound we can obtain the aromatic compounds as our last product. So the secondary step, so this is the secondary step or secondary reaction. This secondary reaction will regain its aromaticity. So this will regain So this is the quick overview of the polycyclization reactions. There will be two main steps. First thing is the concerted reaction step, which is that the bond breaking and bond forming happens simultaneously and you will have non-aromatic polycyclic compound. After that, the secondary step would happen. The secondary step would result in regaining its aromaticity and obtaining our final product. So let's see the mechanism and exactly how this will happen. So at first what happens is a new bond will be formed between this carbon and this carbon. So in order to form that, we have to break these bonds and form new bonds simultaneously. So I will take a new color, let's say blue. Okay, what happens is I will break this bond and form a new bond between these two carbons by taking an electron from here and here. As you can see now, when I take an electron from here, one electron will left out. So I will use that electron to form a new bond between these two carbons. So here I have one electron and I will take another electron from here. Now when it comes to this bond, you have one electron left because I have used one electron to form a bond here, and the other electron I will use that to form a bond between this carbon and this carbon. So here I have one electron, I need another electron to form the bond. I will take that electron from here. So result from this particular reaction is this one. As you can see, we have two bonds. We have two bonds, this one and this one, and the newly formed bond between these two carbons, right? And we have two hydrogens also. These hydrogens, otherwise this particular position is the reason why we don't have the aromaticity. So this is a non-aromatic polycyclic compound. Okay, as the secondary step, right, as the last step, the aromaticity will be regained by removing this hydrogen and form a new bond between these two carbons again. So this is our final product. So I hope you get the idea. So what I want you to know is the difference between the first step and the second step. So first step is always considered reaction step. So bond breaking and forming will be happen simultaneously, while the product of the first step is not aromatic. That's very important. The aromaticity will be regained after the first step in the secondary reaction. So let's do another little advanced example to see the effect. So here I have also drawn the structure so we can easily go with the mechanisms. Okay, so let's see how this particular reaction would happen under these circumstances, right? So let me draw these two bonds. Like I have missed the bonds. There are bonds in these cases. Okay. Now, if you remember what we have talked about, right? So there are two conditions. The first step should be concerted and the product would be non-aromatic, and the second step would regain its aromacity. Now in this case, the reactions don't have to be exactly radical mechanisms, right? So here we have talked about a radical mechanism, but here you will see that this reaction will undergo not with the radical mechanism. So here what happens is just like this. So here we have a bond over here. This bond, so let me take a highlight color. Yeah, let's take blue color. So this bond will move to this position. Now due to this bond will pull out to take the oxygen on this one. Now due to this, right, the nitrogens, the lone pair of the nitrogen will come over here to form a double bond. Now you will see this carbon is getting destabilized, so this bond have to move out to form a bond between this carbon and this carbon. So this is the product we have obtained. As you can see, the bond breaking and bond forming happens simultaneously, right? And we have a product which is a polycyclic compound and it's not aromatic. Now here we have the negative charge on the oxygen. So this is the first step, which is the concerted step. Now at the second step, right, the aromaticity will be regained for our structure. Now in that case, you will see, now if you look at the structure over here, you will see that we have a negative charge and the nitrogen has obtained a positive charge. Now in the second step, what happens is this lone pair will come over here to form a double bond. So this carbon getting destabilized. So this bond will shift to this place. Now you will see this carbon getting destabilized. So what happens is this hydrogen will be removed and form a double bond between these two carbons. Again, this hydrogen will also be removed and form a double bond between these two carbons. And this double bond, or else this pi bond, will come back to this particular nitrogen, right, and form its lone pair back again. Now here we have the structure as our final product. So I hope you get the idea about this polycyclization reactions. So basically there are no strict rules that these have to follow radical mechanism. So it will depend based on the situations. I hope you get the core idea of the reaction mechanisms. So if you have any questions, please feel free to comment below. I will try my best to answer those questions. In our next video, we will continue our discussion about the photochemistry and photochemical reactions.